Hey, thanks. This one is working?
Yeah.
So,
ये आप switch it on.
hello? Yeah. So everybody able to hear me? Okay. So yeah, today's talk is, so mic is working, everything is fine, people are settled. It's a good start, right? So today's talk is about having a good start. We all love having a good start. A bit about myself. I'm a Python developer. When I get stuck on dependency issues, or like I'm not able to just do my work, that is the interesting stuff, developing things, I get stuck involving like installation issues. So this is how to get rid of those issues. So we will need 5 different components which we will be using to build our dev env, which are Docker, Vagrant, VirtualBox, Shell script, and some good luck. I will talk about what is good luck here. And this talk is going to be about more on the whys and less about the hows, because we are all smart and everything is on the internet. You can get most of the infos, like how Docker works, and Linux containers, etc. Okay, so you are running your company, you are managing a team, or you are a developer doing something. It starts from the developer's desk, right? So developer time is very costly for the enterprise. You can easily relate to this fact that hourly cost of developers is equivalent to the monthly cost of servers, right? You hire a developer for $20 an hour or $50 an hour, and you get a AWS EC2 instance. You are going to it's going to cost you about $50 for a month. So yeah, developers are costly. Less productive developers increase time to the market, obviously. So for some reason your developer team is very productive. They have a lot of issues installing stuff, dependency issues, not able to get things running for a new developer in the team. In the new team. And all these reasons, all these cases are potential bad for bad product. You plan to launch your product in February 2015, and it all delays up to say December, and you lost to your competitors. So productivity is very important for your team. I don't know if you are able to make much of this slide at the back. I will just make out the components. So how does a developer workflow look like? So we have a developer. He does his local tests. This cycle is like frequency, right? We do this thing very frequent, and then it goes for QA, and then to the production. So developer to production, this is the least frequently executed thing, and developers local tests, this scenario is the highest frequency. Okay. And one of the stats says 95% of developer time is spent in the development environment, which is very true. So we need to optimize here. This is our interest, right? We are going to optimize this thing, which is the development environment. So how should a development environment look like? I mean, ideally, should be production-like. Sure, for sure, because if you are very my stuff is running on my laptop, my friend's laptop, but it's not running on the production where the end users are going to face the app, it's of no use, right? It should be very quick to set up. Obviously, it takes like 4 for my dev env to set up my app so that I can start working, or the new developer starts working on it. It's not useful, right? Repeatable and upgradable. Quick to set up is one thing, but other team members are going to push their code each day, other day, and we need to have to make the setup repeatable and upgradable as fast as possible, as easy as possible, and simple and easy to use. If you ask me, you can use Chef, but for that you will need to know a new programming language. I don't like that. It should be something like, by default, everybody should be knowing it. It should be very easy, and people shouldn't be required. The learning curve should be very low. They shouldn't require to learn a new language or a new DSL or things like that. So yeah, simple and easy. Like if there is a way, you write one line there, and a very complex app which with lot of components, multi-tier application architecture, magic. So that's cool. That's a feasible solution, and that's the wanted thing here, right? So say a modern picture, what it looks like. It has, say, one component is Nginx. You have your Flask application with Cassandra data store, some XYZ server, maybe TCP server or UDP server for whatever reason, I don't know. RabbitMQ, Elasticsearch, all these cool stuff, right? And then you want to just recreate these things. You have RabbitMQ cluster, and but at the least, you want to recreate these things, these components, in your development environment. Yeah, one way is to have one VM, like one VirtualBox VM running for each one of these components. This is one way. But if you have like 6 components and you are planning to run 6 VMs on your laptop, I don't know, it's very good thing, very good thought. And what just today, Michael Ford talked about the dependency hell. Like you have 2 applications. One is Flask, and it depends on some library version 1.0, and other Flask application, for some reason you are using one more application, and that is using 1.2. And you need to of these applications in your same system. So this is the problem. So the solution we are going to talk about solves all of these issues. So yeah, here is Docker. So what is Docker? Docker, most of you, like if you are not much into systems level, Linux containers and those kind of stuff, very easily you can think of it like a lightweight virtual machine. That's it. You can take it as like this, and you can work on it. I don't say that don't dig on it like details on the details, but you can use it by just knowing that it's a very light virtual machine. Other than that, the main big win using Docker is it's pretty fast. I mean, starting a VM takes you 2 minutes to 5 minutes, maybe. Starting a Docker container takes you milliseconds, or in seconds, 2 seconds. Right? So it's very fast. So yeah, instead of running VMs, we will be running containers. So how are we going to do that? Okay, some introduction about Docker. So Docker has this concept of images and containers. If you are familiar with AWS, so they have this concept of AWS AMIs, right? AMIs are the images, run the instance, the running instance, EC2 instance, that gives you a running operating system. So in a similar way, Docker has Docker image, which is the OS image, and when we run it, they call it Docker container, a running container, right? Yeah. About Vagrant, the 5 components I talked about. What is Vagrant? So Vagrant is a provisioning tool. You can use Vagrant to provision a EC2 instance, remote server EC2 instance. You can use Vagrant to provision a local box, virtual box. You can use Vagrant with Ansible or Chef or these kind of other tools to do a lot of interesting stuff. But we are using Vagrant with a bunch of shell scripts to build our DevEnv. So the problem I'm trying to solve here is I'm a developer, and it's my preference. I love writing my code on a Mac. And my friend, maybe he loves writing his code on a Windows machine for some reason, and another one, he loves writing his code on Ubuntu. So, and we all join the same company, and if we would have a way that this thing could be feasible, I don't know. So, is it feasible? Sure thing. We are going to implement that. What we are going to do is this is my laptop, and I am sharing with the machine running inside the laptop, VirtualBox thing, okay? And the virtual machine will be hosting different components of the multi-tier application stack, different components. Each of these components is a running Docker container. Nginx, XYZ server, RabbitMQ, these components don't need the code, and application code. But yeah, the Flask app, this needs the application code, right? So there should, if this Flask application is able to view code which is residing here on the host operating system, the laptop, not the VM. Someday, I edit this thing visible to this Flask app. We think the feedback loop, what I'm talking about is a developer needs to have a fast feedback loop. If I change something in my template, like I'm just editing a HTML template, and I want to see how it goes, so I must have a way to see it immediately. Okay, I don't want to push to GitHub and then see things on a test server, things like that. So I change my code here on my laptop in a platform agnostic way, may a Mac, Ubuntu, anything, and the Flask app here sees it. It changes the application right away, and I can see the app running changes on my laptop. How is it going to be possible? So we are going to use two key. One is shared volumes, and another is port forwarding. So, okay. Could you help me, please? I want to show the editor. This is not show this screen. It's not coming. It's coming back. Are we doing multiple screens or? Okay.
Use a Mac, so we could ask the person who uses
You need any other way?
Huh?
Shall I provide you?
I will.
I have Ubuntu.
Okay, leave it. Oh, I got it. Okay. How it's coming? Okay, on the other screen, right? Fine.
yeah. Now you
On the right screen, right?
Just change the
you see that?
Yeah.
But you don't see it.
Yeah. So I can do that. We'll
the
just.
screen
Yeah.
display option.
I got it. Yeah.
It's like your virtual
Uh-huh.
screen is here. Okay.
Good. Okay. Sure. Okay. So in our Docker, Vagrant file, we are specifying two things. One is the port forwarding, which is saying, let me get the app which is running on the virtual machine at port 80 and make it visible on my laptop, say Mac or Windows, on port 8080. Okay. So anything running on your virtual machine under the VirtualBox at port 80 would become visible on port 8080. And the Vagrant file has a concept of like provisioning script. So we are providing, okay, this is the provision.sh shell script, and that basically Vagrant up, start our dev env. It runs that particular script at the startup. So it's something kind of the user data concept which AWS is having, okay? Okay. So here I go with my development setup. I just wrote a one-liner, and it should start my full app running with all the components, like I am running Elasticsearch and whatnot. Okay, simple search application. Okay, it started. So you can see the app running here. Yeah, this is my Mac. The application is running under Linux. Yeah. And now I will show you, I change the code on my editor, and it should be right away visible. The change should be right away visible on my application where I'm running. See, I just change this template. Instead of my application, I write our application maybe. Okay, and then so So as you can see, the title there is my application, and it changes to our, the change is right away visible. So good thing about this is applications can become very complex, and when you have your when you have in your team a developer who is a front-end engineer and he doesn't like to think about back-end systems, it may be very interesting to some of people like back-end. Some people like designing things. They are CSS developers or HTML5 developers, and they want to focus their skills on the front end. So it's not right for us to just bog them down with backend details. So however complex your application is, the developers come, the front end engineer comes up, he does the CSS changes without worrying about how this application is getting deployed or how complex is the architecture there. He can simply work straight away, right? So this increases the productivity for a lot of people who don't want to get into much details of every component. I remember like 3 years back, I joined one company, and it got them, like it took them 4 to 5 days to just set up a dev env, like a full application running for me where I could start my work. So this is a problem it's very kind of everywhere I see this. So the dev env should be very fast to set up, and it shouldn't be getting into our way, just like the problem with the front end is everywhere is. Okay. Okay, back to the presentation. So what is minimal impedance mismatch, which is our target? The thing is like we want a high fidelity resolution to the production on our dev env as close as possible. Say if your production, in principle we could have just done away with just one Flask app. the Flask app to our developers. They work on it, and assuming that everything would run fine when they deploy it to production with all the moving parts like Cassandra and whatnot. But yeah, that way it doesn't work. Like things could go, and a lot of possibilities there. So it's actually imperative that we want all of the components as close as possible in our dev env. So that is minimizing the impedance mismatch between the production and your development environment. So how is this? How are we going to achieve? So what is Dockerfile exactly? So Docker has this concept of Docker files. Docker in itself, Dockerfile is not very useful. I have been using Docker for a year now, from version 0.7, and I did a lot of dev envs for a range of applications from Internet of Things, computational genomics. Dockerfile in itself is just a DSL, which has some directives. It is just like a shell script. So if Dockerfile was that awesome, then why shell is not? So actually Dockerfile is not. It has just some directives to let out the Docker daemon or the Docker software work. The problem with Dockerfile is you run your Dockerfile to build the images. It may work today, and it may not work tomorrow. And just today I had this problem. I was in Audi1 and trying to build using my Dockerfile. The net was not running, some issues up. I had to go and then get back my image. The image is the immutable thing. So it is not getting destroyed or it is not getting corrupted. Problem with Dockerfile is it's shell script. Going to depend on a lot of third parties, exactly like a shell script, right? So how does a Dockerfile look basically? What happened? Cancel. Okay. So shift command home. Okay. Docker. Search. Yeah, it's okay. I got it.
Enable mirroring. You can both.
Yeah, it's doing a lot of problem to me. Just do the mirroring thing. Yeah, thanks. Okay, so this is how a Dockerfile looks. So we have this line. It's building on a base image, which is like from Dockerfile Java, whatever. This is a base Ubuntu image which has already Java installed. So right here, like it depends on somebody's else image, else code, right? So you cannot depend on that. And this Dockerfile is working today, and 1 month from now, you try again building it, and the person who made this image, for some reason, he changed everything, right? And you have written the same image name, and things don't work. So you cannot rely on Dockerfiles. The only thing which you can rely is the Docker images. So what that means is you build your image, you have this image, you use the same image for your development and for your production. No change at all. And that image is basically your full environment, runtime environment, including the OS, including the libraries, and including the app code and everything. Everything, basically. That's in your Docker image. And next time you want to build one, first build one, have a successful build, test it, try it, everything, and if it's working properly, then you can replace your old image. This is the only thing that's going to work. So you cannot rely on Dockerfile, for sure. Okay, and how are we going to, like for the DevEnv, how are we going to solve the problem of having a snapshot of the database inside our DevEnv? So one of the projects I worked on was Auto.com, and they had this like 60 to 80 GB of data, and we didn't want to pull all of it into our DevEnv. We wanted some lighter version of it, I mean a subset of it. So one way was to just randomly select, some sample points and have it and get it every 24 hours so that we get the latest snapshot. But what happened is some of the app scenarios which depended on some specific data points was not working. We were not able to test it. So that is where the selection strategy comes. You need to select a good strategy so that every component of the app which you are going to work on has the data. You can see all the features working. It shouldn't be something like, okay, like you have a real estate app. For some reason they have done their section for Delhi, Bangalore, and Chennai. And your data, the data snapshot you took, it was just for Delhi and Bangalore, but not for Chennai. And you never tested it because the data was not there, and there were some issues with the Chennai thing. So you won't be able to catch it. So it's very important when you are building the snapshot for your DevEnv, have a good strategy that spans to all the app, all the scenarios which the app features needs. About host names. So on the production, we don't usually work with IPs. We work with host names, right? So I have a MongoDB cluster. I will be using it as mongodb.immunodiet.com or something like that with a URL. And on the DevEnv, when we are talking about minimizing the impedance mismatch between production and development environment, we want to have similar thing here on the DevEnv itself. So how are we going to do that? Yeah. So Docker has, in fact, new release Docker, they have many features on editing the etc host file dynamically. But the thing is, yeah, this is the solution. So on the local dev, basically it overrides a DNS, and when you go to auto.com on your local system, it connects you to the local container, not the real web application. So when it's in the DevEnv, it works exactly like when it is working in the production. Okay, all of the source code is here on my GitHub account, Anubhav Sinha, PyCon 2014 India. Thank you, and I'm ready for QA. Docker is built upon LXCs, right? Docker didn't invent LXCs. So Docker is just giving developers a good user interface for working with LXCs, right?
So you need but at the end of the day, when you're using a Docker, right, it's process isolation more than a virtualization technique. Mm-hmm. And when you're dealing with a complex web app or a set of web apps and you're trying to script in databases and stuff like that, mm-hmm. then how do you deploy code synchronously across these Dockers in a fashion? And also, I mean, is there any particular reason you're trying to build your own Docker file for stuff like Elasticsearch that comes out of the box with its own Docker images? Yeah.
So yeah, I didn't build that Docker file. I put it here just an example how the Docker file looks. I am using the exact from the off-the-shelf Docker file, which is available from the Docker Hub, Docker Index. But when you have a very when you are building a custom application, you are not like you will have a Elasticsearch config file, a custom file, right? So for that you need to change. I mean, you can inherit from the base Docker, Elasticsearch off the shelf, but you will need to change some of the stuff. So about deployment is like, okay, I missed one of the concepts is the registry, right? So registry. So like some people have this preference, they don't want to share their code. The companies don't want to share their code with other cloud providers, maybe Docker Hub or something.
I know, right? You're talking about a registry where I can push. Essentially, I'd
Private
say
registry.
Docker is Git for deployment,
yeah.
right? Now, if I'm using a certain Docker philosophy, at least what the Docker deployment philosophy dictates, or what has emerged today as the way to do large-scale deployments, is that you use environment variables. Your Docker files pick up environment variables from the host, and those can be passed along into the Docker containerization or LMCT5 or whatever you use. Then why would you want to expose disk data binds and then modify them through another bind over there? I mean, it just causes complex. Like sometimes you have AUFS lockups on Docker. Like Docker does not give you the full flexibility of Btrfs that LXC would give you.
But they are I think they are having. I mean, you have the option to use different drivers, right? I mean, that's the default one, right? You can use many other drivers with Docker. So it's not a lockdown there.
Because of the isolation it gives at the OS file system level, but I don't know. I mean, there are no drivers.
I'm not able to understand your question actually. What is the question exactly?
Why are you using Dockers in places where you would rather use an LXC?
Use environment variables to modify
your Docker files.
Huh? Huh?
Where you just relaunch it and it picks up stuff from the environment. Like your hostname is simple -x whatever, or your file is also an environment variable. Everything is environment variable. You're not supposed to modify config files anymore. I mean, it is pretty funny. You really don't use config files for managing Docker.
Yeah, you are right on that. We don't use config files for managing Docker, but config files are like, for example, so you are saying like I have to change the config for Elasticsearch, I put it in an environment variable, right? Yeah, you can do that.
You put in a working directory, share it, and ask it to pick it up the config file from there. If you're using something which doesn't.
Yeah, I think you are right there. Yeah, that's it looks like a right approach. Yeah.
How can we configure different subnets in using Vagrant? Is that something we can do?
I have not tried doing a lot of stuffs and subnets on those stuffs using Vagrant, so I don't know that much about those.
Okay.
Kind of.
Okay, thank you Anubhav. We thoroughly enjoyed your presentation.